You're standing beside the massive floor-to-ceiling window of the spaceship, your home for the past 12 years, along with a few hundred others. Outside, an unfamiliar object drifts closer. It resembles an asteroid, but moves like a comet, as if propelled by some unseen force. Could it be an engine created by an alien civilization? Is this the end of your journey, or the beginning of first contact? Let's set aside this sci-fi scenario for now, and explore the reality behind these mysterious celestial visitors, dark comets. The most pressing question: what's making them move? Scientists believe it's due to gas or material escaping from their surfaces. Interestingly, until just a few years ago, we weren't even sure these objects existed. The first dark comet was discovered recently, and since then, researchers have identified 14 in total, including 7 new ones found just in the past few years. The story of dark comets began in 2016, when astronomers noticed something unusual about an asteroid named 2003 RM. Its orbit was slightly off, shifting in a way that couldn't be explained by normal asteroid behavior. Typically, sunlight heats an asteroid unevenly, causing minor changes in its path. But in this case, the movement suggested 2003 RM was releasing material, something comets do. However, there was a mystery. It didn't have a tail or a visible gas cloud. It looked just like an ordinary asteroid. Initially, scientists thought 2003 RM was an anomaly, but in 2017, telescopes detected another strange object, this time from outside our solar system. It was Oumuamua. It, too, resembled an asteroid, but had an unexplained change in trajectory, as if gas was escaping from it. The similarities between Oumuamua and 2003 RM led researchers to suspect that more such objects might be lurking in space. By 2023, 7 more had been discovered within our solar system. These discoveries were enough to classify them under a new category: dark comets. Now, with enough data, scientists have identified 2 major types of dark comets. The outer dark comets are large, sometimes hundreds of feet across, and follow elongated orbits, much like traditional comets that originate near Jupiter. Meanwhile, inner dark comets are smaller, just a few dozen feet wide, and travel in nearly circular paths, staying closer to the Sun near planets like Earth, Venus, and Mars. The big question remains: where do dark comets come from? Could they be fragments of larger celestial bodies that broke apart over time? If so, they might hold vital clues about the history of our solar system. Some scientists even speculate that dark comets once carried the building blocks of life, delivering essential elements to early Earth. If they contain ice or organic compounds, they could have played a crucial role in spreading water across the solar system. Research suggests that certain asteroids in the asteroid belt, a vast region between Mars and Jupiter filled with rocky debris, might have hidden reserves of ice beneath their surfaces. This ice, in theory, could have migrated into the near-Earth region, possibly contributing to Earth's water supply. While no one can say for certain that dark comets brought water to our planet, they may serve as a mechanism for transporting ice across space. There also appears to be a link between dark comets and Jupiter family comets, a group of comets whose paths are heavily influenced by Jupiter's gravity. These objects are often drawn inward toward the Sun, making it even harder to track their origins and behaviors. Now, let's compare asteroids and comets to understand why dark comets are so unique. Traditional asteroids are rocky and orbit relatively close to the Sun, within a region where ice cannot survive. Meanwhile, comets form farther from the Sun, where it's cold enough for ice to remain solid. When they move closer to the inner solar system, their ice turns to gas, forming a visible coma and tail. Dark comets, however, don't fit neatly into either category. They look like rocky asteroids, showing no visible tail or coma, yet they exhibit subtle, comet-like accelerations, tiny shifts in their movement caused by escaping gas. After analyzing 7 known dark comets, scientists estimate that anywhere from 0.5% to 60% of all near-Earth objects might belong to this mysterious category. This suggests that ice could exist even in asteroid belt regions previously thought to be too warm for it to survive. Unlike traditional asteroids, near-Earth dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for only about 10 million years. Given that the solar system is over 4.5 billion years old, This means that new near-Earth objects must constantly replace the ones that are lost. To better understand these objects, astronomers have used advanced computer models to simulate their movements over 100,000 years. The results show that many of them migrate into the exact regions where dark comets are found today. Remember 2003 RM, the first identified dark comet. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning again, a trajectory that perfectly matches that of a Jupiter family comet. This suggests that it was likely nudged inward from its original orbit. However, most other dark comets appear to have originated closer to Mars, within the inner asteroid belt. One intriguing characteristic of dark comets is their rapid spin. Astronomers often describe them as dirty ice cubes, a mixture of rock and ice. As they cross the ice line, their ice sublimates into gas, causing small accelerations. This process not only changes their trajectory, but also increases their spin rate. The faster they spin, the more likely they are to break apart into smaller fragments. As these fragments continue spinning and breaking apart, they shrink further and further, possibly explaining why dark comets are so tiny, and why there might be far more of them than we realize. Studying dark comets offers valuable insights into the movement of ice within our solar system, and could answer fundamental questions about the history of water on Earth. How much ice remains hidden in the asteroid belt? Did dark comets play a role in delivering essential elements for life? And if these objects make up a significant portion of near-Earth bodies, what does that mean for our understanding of potential asteroid threats? Fortunately, with modern telescopes and sophisticated simulations, scientists now have the tools to uncover the secrets of these enigmatic objects. As research continues, dark comets may hold the key to unraveling the mysteries of water, life, and the dynamic forces shaping our solar system. That's all for today. If you found this exploration of dark comets fascinating, like the video, share it with your friends. And if you're hungry for more cosmic mysteries, click on these videos and stay curious.